I welcome Marissa, Roxanne, and Amanda to give their presentation concerning hands-on to online with Material Chem tutorials. Please give us some information about that, Amanda.
Awesome. So welcome everyone, our first session this morning. I am Amanda. I'm an instructor at the University of Calgary. And with me today are my teaching and instructional assistants, Marissa Clapson and Roxanne Jackson. So we will tell you a little bit how we moved a very intensely hands-on tutorial component of our Materials Chem class to accommodate our completely online mode this past year. Maybe, there we go. So in past years, our tutorial sections in Chem 379, which is Materials Chem for Engineers, have been 8 weekly tutorials where we did a lot of group work, and you can see some of the activities ticking by there. They've been very hands-on, game-based activities, some escape room activities, manipulating models, and you might have seen some little molds flashing by there where we actually took 2 weeks and had our students make a design and make their own bioplastic material. So moving into this past year, like with so many other people, we had mostly the same course structure, but all of it had to move online and be hosted through Zoom. We didn't have any on-campus access for our students. Many of them were not even in the country, so we couldn't do things like give them kits to do the activities hands-on at home. So we had to convert everything to a completely online structure as we went. So we used a few different methods to set that up. And we'll go through a few of the more and less successful ways that happened.
Amazing. So as you probably saw in the flashing images, there was a set of cards that said act and explain. This comes from our Act, Draw, Explain Your Science game, which was a big hit. Essentially, it was a hybrid blend of charades and Pictionary. And so to try and bring this into an online framework, it's much harder to be necessarily acting and explaining. But we did find this wonderful program called Scribblio. So essentially, it's very, very similar to Pictionary, where in real time you can be drawing your chemistry images while your teammates play along. The bonus of this is you can input your completely own word list. So we had all of our functional group naming, different geometries, things along this line. And students were able to work together. Some pros, these rooms are incredibly easy to set up. The program's thankfully ready to go and you just need to input your word list. Again, you can choose essentially any word, so it's highly applicable across a lot of chemistry classrooms. It's fun and engaging. As the TA that sat in on all of these games, students, I don't think I've ever seen them more talkative than when they were playing these games, and there was a lot of really good feedback. The bonus of this game as well is even if you're not the fastest to guess what the answer is or what the drawing is supposed to represent, you can still get points for being second, third, and even fourth as long as you get an answer in there. Another bonus is you can perform this without Zoom. So if you want Zoom, they can be chatting together while they play. You can also do it completely without, and they can still see all their responses and chat in the sidebar. I'd say a couple of the downfalls of the program is that you either have to publish the word list and share it with your students ahead of time, or you have to host and create all the rooms yourself, which is the method we ended up choosing. How many people can be in a room at once? Great question. There can be 12 in a room at once. The only other downfall is because if you are the host or the TA sending out all of the links, you don't necessarily know the URL links ahead of time. So you do have to set the rooms up separately for each of the 12 groups. And there's no extremely easy reporting method. So we did ask students to report their points in order to show that they've been participating, but you can't through the program necessarily just hit, download or print so that they can easily do this. So it was a lot of self-recording when it came to points.
For our card and board games, we used the free website flippity.net to create matching and board games that were then playable online by the students. You can see a quick demo of these games in the slide animation. Flippity uses a Google spreadsheet to track the contents of the card deck. So it was quite simple to set up and edit the content for both of the games that we used. Using Flippity also let the teams access their own instances of the games all at one time. Although that meant one of the persons in each group had to control the board and share their screen with the rest of their group so they could play together. There are also some content limitations. There's a maximum number of cards supported in the deck. They're also not stored, so you couldn't collect a hand of cards as you do in a typical board game.
So our other activity that we had was an escape room puzzle, and to move that to online, we used Qualtrics survey software paired with an offline or on the side PDF workbook. So students watched linked from that workbook demonstration videos. You'll see a little clip of one pop up in the animation, and they read background information in that workbook and then answered follow-up questions through this survey that you're seeing online. Rather than having a correct answer give a clue to a lock combination like in our original escape room, answering a question correctly would just unlock access to the next question in the series in the Qualtrics survey. So groups could try each question as many times as they needed to get the answer correct, but the more attempts you had, the lower the score you got was. So if you got it right on the first try, you got full points, and then fewer points the more attempts you took to get the question right. This activity did use Qualtrics' ability to assign points to be self-scoring. So this was one of our only ones where we could actually assign points to the activity without having to go in and set them up ourselves. And you can structure the questions to be pretty much anything you can find a way to fit in that library of question types. So multiple choice or sorting, there's lots of options there. We could also add hints to questions. So on your second attempt, we could give you a little bit of a clue to get you unstuck. And you did get a little reward. It's not super obvious. I think it got cut off in the animation, but you get a little congratulations message and a ta-da emoji when you get the question right. So you do get a sense of progression through the activity. It did take a bunch of time to set up initially and program in that answer behavior. Figuring it out the first time through took a little bit of time, but we only had to do that once. Additionally, Qualtrics itself isn't free software. We have a site license at the university, so it didn't cost our course anything, but other locations may need to either find free software or get a license to use this particular website. From our students' perspective, getting a little ta-da emoji is a sense of progression, but it was a little bit less exciting than actually opening a locked box. But they did seem to enjoy this activity overall, so Marissa can probably comment on that, but it was another one where people seemed to be really engaged with progression through the activity. And finally, we took our materials synthesis exercise and turned it into a sort of video-based choose your own adventure activity. In the first week, students chose an application for their material and what properties they need their material to have from a list of available combinations of starting materials. And we chose a subset of the available combinations to make videos like the clip you just saw and perform tests on them that were recorded. So students chose which material they wanted to test and what tests they'd like to apply to it. And then in the second week, they reviewed those videos, made observations based on them, and decided whether their material met or didn't meet the criteria that they needed for their particular application. They could also compare their material if some of them were total flops. I showed one that worked. There were some videos that it's kind of hilarious. They're softer than Jell-O, and our tech recording the video, it's just a splat as the material hits the floor. And so they still had some space for failure in there and preserving that sense of choice and ability to make wrong combinations in that activity, which is actually an important factor there. Overall, these videos aren't as engaging as actually making those materials and testing them yourselves, but it was the closest we could get online. And the students did have that limited number of combinations to choose from. So that was just our own restriction in time for filming. So that was a few more and less effective ways to do it. I'd like to shout out some thanks to Patrick Yu, our tech, who filmed the demonstrations, Brian Gilbert, our TA in the past year, who helped develop the in-person activities, Marissa and Roxanne for developing and running stuff online and helping present today. And I can throw those links in the chat if you would like to actually try any of these games that we showed you today. And thank you for being here and listening.